noise and vibration within the explored facility. Let's just focus.
Good morning. So my name is Annan. I have been working at that around 8 years now. I'm in the high performance building design team. We do many studies, including energy modeling, sound analysis, wall compensation analysis. So many projects that are concerned mainly with sustainability. So basically the papers that we try to publish every now and then are case studies to the projects that we handle. Most of our projects come they differ. Every time we encounter something, it's interesting that not all projects are the same. So today I would like to speak about sound analysis, mainly the prediction and control of noise. We mainly see it in auditoriums, we see it in universities, in houses, in malls, but in sports facilities this is new. So when I speak of a sports facility, we consider many items: the technical rooms, the occupied rooms, the outside roads, commercial streets. So today I will introduce this. I will tell you how we design and some simulation results, some survey analysis conducted on site. This project took place in Dubai. So obviously occupants perceive noise as undesirable sound. And we as designers, we try to evaluate what is known as reverberation time. And this time is required for the very loud noise to decay to inaudibility. So we're capable to perceive the occurrence of sound, distinguish the levels of the frequency, and identify and localize the diverse speech sounds. So this is common, we can tell from this scale, which is comfortable, which is not. Okay. So, as designers, we must achieve a suitable reverberation time, RT. We control undesirable discrete reflections. We maintain proper with equal distributed sound levels. And the specifications are mainly the room volume shaping, selection of good finished materials for walls, floors, and ceilings. Today's study will include the environmental simulation, external mechanical equipment simulation, and the noise survey that's conducted at night and during the day. Okay, so here we can see, basically I will tell you how we will target, how we start studying a room. So internal sound simulation should be designed to provide suitable level of acoustic privacy, obviously, between noisy areas and occupied areas. Here, there is a list of two types of gypsum insulation. So we have 80 and 50. What's important is to check the STC, which is 50 and 55. Those are typically used as we typically use them. However, if we tend to use another thing, we have to stick to the STC level to maintain 50 and 55. And why should we stick to them? When we target any project, we have the ASHRAE and we have the local standards. So this is in Dubai, this arena is in Dubai, so we have to study both. And obviously we have to go with more stringent reference. Moving forward, the walls also should be plastered from both sides, 15 mm. And another block wall properties, as we can see, the STC for the hollow block and the solid block as thickness. Moreover, the doors should provide sufficient sound isolation. For the walls of 50, we need to provide also respective doors STC levels 30, 35, up till 45. For the floor constructions, also we need to achieve an STC of 60, which is acceptable for reducing airborne noise. Sound absorptive materials tend to reduce sound transfer. Currently, so within the arena itself, if there's a lot of cheating and we need to reduce the effect on the humans, so there are sound absorbing materials that are actually installed. And what we do as designers, we have people on site that measure the noise during and before installing the sound absorbing materials and after. And this can actually be tested by a survey that is also conducted with the people actually being in the arena. So design aspect includes everything from room volume shaping to selection and placement of finished materials. I'm speaking generally because this finished materials is also within the arena. There are changing rooms, I'm coming to this, technical rooms, occupied rooms. There are outside commercial streets and residential streets, even mosques. So when a study like this comes at hand, we need to take into account everything, not only the people actually attending the event, the people sitting close by or within the event and not attending the event, they should also be in a comfortable mode. So this, speaking of this, those are sample rooms that were targeted in the paper itself, but here I'm only showing the spectator concourse where I use some required interior finishes to achieve the required reverberation time that I spoke of earlier. So, example is the emulsion paint, which we can see here, and the epoxy flooring, the perforated gypsum board, and wooden acoustical baffle ceilings. So all these absorb the noise that is within such rooms. Moving to the simulations, environmental noise criteria has been extracted, as I said, from the technical guidance. This is from Dubai municipality because this arena is within Dubai. It's not necessarily Dubai. We have projects in Doha, Oman. In all regions, they have their local codes, so we have to stick to them as well. The case study is mostly similar to this range, which is during the day and during the night, residential areas with some workshop and commercial areas. Here we can see the 3D model of all of everything targeted in the study, like the roof walls, the dine and view, and the rock shows. So now my study is to maintain this difference, 50 to 60, and not exceed it during the night or during the day. And when we're short on info, we tend to take surveys, or we tend to find older surveys that were taken before us to compare and have it validated eventually. So the noise propagation is modeled using a modeling software. We're not allowed to say it, so but I'm willing to speak of it afterwards. So the frequency, we always test the noise, obviously, by having this frequency spectrum and the noise at every level of frequency. Internal noise spectrum of a typical rock event and sound insulation performance of the roof. So this, after doing the simulation, we can see from these colors that the noise is between 37 to 40, which if we go back, it's within the range. So results are within the allowable limit of noise required. This is an example of an insulation and in a roof composition is taken as an example. So also we can see that this middle panel, the rock wall gypsum panel, they ensure that the noise breakout is achieved. And this is another specimen of how perforated it is. So now this is let's say a map of what we study around. This is the arena. This is the royal VIP places. The drop of. So mainly we studied these locations from 1 to 9. So the noise generated by the existing plant power and the noise in the area around the mosque and noise during the daytime and nighttime. This is done specifically for this project. However, if the client, let's say, has a specific, he finds that this room is not comfortable, the people within it is not comfortable, this can be also conducted additionally on other, so the simulation can be conducted on different rooms, indoor and outdoor, and depending on the simulation tool, we can we can do the study. So, as I said here, a noise survey was realized on 31st of October and the 1st of November 2016. The survey included 9 locations, and as I'm mentioning here during the day, the times here, which are important of course. So the traffic also study was steady and generally free-flowing. The measured data ranges between 55 and 75.8, according to the location of the sensors, which satisfy the needed requirements. Another survey was conducted on 2 locations, one for a residential street and another for commercial street. And the survey showed that what caused the noise is the stone pavement of the road, the presence of road bumpers, presence of motorcycle and sports car, and technical plants. This, as a mechanical engineer, I go back to my rules, which we always test the air handling units, the technical equipment. This is basically what we should be interested in. But since we're studying the acoustic analysis itself, we're going into all other parameters such as the finishing and the wall, which are more into architecture. So the measured data at different locations ranged between 58.9 to 60.1. The noise breakout from the arena satisfied the external noise criteria, and the noise break-in was also assessed by the survey conducted in 2016. So it's expected that the arena will meet the minimum noise requirement. Finally, the last simulation that was done was using the HVAC, which basically are air handling units. The noise criteria describe the maximum background sound level due to the normal operation of equipment. So acceptable noise levels are listed here. For restaurants, we have noise criteria of 40, VIP rooms, media room. We have to stick to them. We cannot exceed those noise criteria. We can see also a list, the frequency levels or spectrum of each air handling unit. This is specified by the supplier selection. So the supplier sends us a selection of each air handling unit. We have to always stay in touch with the suppliers because sometimes air handling units exceed the noise criteria and the supplier is aware of that. So he also provides a silencer or a way to decrease the noises for this equipment. The critical receivers are located at 1.5 or 1.65 meter, which is the average human height above ground across the entire facade of an adjacent mosque, with an allowable limit during the daytime and the nighttime, 50 to 60 and 40 to 50. We use, as I said earlier, we have different simulation tool, and since it is for HVAC equipment, we have to use software known as Ghina software, where we have to include all the data input of the selections, the location, and we conduct the survey, the simulation. And then we notice that the noise perceived at the mosque facade is a maximum of 37. 37 is acceptable, 37 decibels, which is acceptable based on the noise criteria we have seen earlier. So the conclusion, this represents a case study of a sports facility that assesses noise produced in a sports facility. The design, first we spoke of the design of the walls, doors, floors, and interior finishes. The study was also conducted an environmental simulation, a day and night survey, noise survey, and external equipment simulation in order to take into account all noise sources. So results of the assessment are within the needed requirements, so no further mitigation was required. Another presentation or papers can be done on the noise mitigation ways. I can also, if you have any questions, I can help on that. We have to make sure that commission expense should be always undertaken because sometimes the equipment they run in a different manner, they might become more noisy. So commissioning is important for such projects. Thank you.
So the floor is open for questions.
How big a sports facility was it? How many seats? How many number of people?
We don't model the seats.
Okay.
We don't model the seats, and even the people themselves, we don't model the people.
Okay.
So
I'm just trying to get a perspective of, is it like 10,000 people, 20,000 people indoor sports arena?
yeah, maybe more.
Maybe more?
Yeah.
Okay.
That confidential.
Yeah. We're not allowed to because it's not yet developed. Yeah.
Cynical question, what is BBIT? Is it very, very
Yeah. Yeah, you know something, mostly in Dubai, in Qatar, and Saudi Arabia.
When is it gonna stop? How many B's will we?
You know, the least office is the manager. This is the lowest, and it's the manager, and then you go up. Yeah, I noticed that too.
So how would the presence of seats and people in the room affect the results of your simulation?
As I said before, it's within the arena. The only thing that we can do is put sound-absorbing material. So it's a relative. It's not basically really comfortable because eventually, if I'm going to a game, I'm expecting to have it noisy. I'm not expecting to have a calm room and different from heading to a spa than heading to a. But relatively, having these sound-absorbing material, I wanted to get 2 videos to show you the difference between the sound generated when we have sound-absorbing material and when we don't have it. But when we do the survey and ask the people on site during the day and during the night, we can tell and sense if they're really comfortable or not. So the maximum that we can do for now, the technology that allows us to do it, is the sound-absorbing material on the walls of the area.
I think also there's a material you can cancel the noise, right?
Yeah.
Did you ever consider that?
Till now, no, but I'm reading about it, so we're trying to introduce it hopefully soon.
Get totally on board. Any other questions?
Do you also look at window glazing systems with transmission through them?
Yes, this is basically done through the architectural team, but newly we have been partnered in with the architectural team to study more about the walls and floors and the glazing. But mainly the glazing, we don't test it because we don't have much of a variety in terms of soundproofing. We have lots of suppliers. Once we want this project to go on, we just ask the suppliers to give us some options. But we don't have a simulation tool to test such glazing, noise levels inside and outside within. We just trust the supplier and the specs supplied by for the glazing itself.
No more questions? So by this we conclude the session then.
Thank you.
Thank you.